extend towards the left until infinity. So along the x-axis, we say this is the domain. So how to represent the domain in symbol form? So we say that the domain from negative infinity to infinity. And infinity is not a fixed number. So you cannot say it is equal to infinity. So you use a round bracket. Here also you use a round bracket because it does not include something which is unknown, infinity. Okay, so we look at the range. The range is something along the y-axis. So for a particular value of x, you will correspond with a particular value of y on the x-axis. So you see that this line stretches from top until the bottom. So we say the range is from bottom here, negative infinity, until positive infinity, until the top there. And it does not include infinity and negative infinity because these two are unknown things. So we cannot say that they are equal to these two things. So this is how we represent the domain and the range for this particular function. Any questions so far regarding how to look at the domain and the range? Any questions?
No.
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 No, then we look at the next one, how to determine the range. Now the second function is y equals to square root of x minus 2. Now this particular function here, y equals to x minus 2, the x cannot take certain values. Let's say, for example, let me show you. Let's say, for example, square root, where's the square root? Square root of x minus 2. Now, let's say if the x is 0, if the x is 0, then we get something like square root of 0 minus 2, which is negative 2. So square root is only defined for positive numbers. You cannot have the square root of a negative number. So that means this x equals to 0, x equals to 0 is not within the domain. X equal to 0 is not within the domain. Now, the domain only starts when the square root is a positive number. Right? Even if it is 0, it doesn't matter. It can be equal to 0 because square root of 0 is defined and square root of 0 is 0. So here, the value of x, how to determine the value of x? We determine the value of x by telling that this x minus 2, this x minus 2 must be greater or equal to 0. Must be greater or equal to 0. If it is less than 0, then it is not possible because square root of a number and that number has to be greater than 0. So that number is this one, x minus 2. This x minus 2 must be bigger than 0. So if x minus 2 is bigger than 0, it means that our x can only take values bigger than this negative 2 over to the other side, it can become positive 2. So in the end, we have x must be greater than 2. So this will define our range for the function. So I say x must be greater than or equal to 2. So what is the domain now? The domain must be, but at least it should be at least equal to 2, right? Then from 2, you see here, from 2, this is 1, this is 2. The x start from 2 is stretches until infinity. So the next one will be infinity. But as I've said, it cannot be equal to infinity. So you put a round bracket there. So this is the domain for this function, x minus 2, square root of x minus 2. This is the domain. By looking at the graph here, the x cannot take all these values, the negative values, 0 and 1 and 1 point something. The x cannot take this value. You see that the graph only start from 0, start from 2. So the domain start from 2. It cannot take any value. You see this line, the blue line, is never on this side of the x-axis, right? So it's not. So it should be 2. Now, by looking at this line, can you tell me what is the range? What is the corresponding value of y? Do you know what is the corresponding value of y? The y is along this line here. So you look along this line.
0.
Sorry?
0.
It starts from 0. Can it be less than 0 here? The line?
No.
No, right? So that means it starts from 0. Then the next one will be infinity.
Infinity.
Stretches until infinity. Right? So this is the range. So by looking at the blue line, you know which part of the x-axis is covered. So the part that is covered is from 2 until infinity. By looking at this blue line, you also can see which part of the y-axis is covered. It starts from 0 until infinity. You see this point here. This is the point. Then below, no more value of y. The value of y is all above. Above. So this is the domain and the range. Next one. Okay, before I carry on, any problem? Do you understand? Can you understand this one?
Yes.
Okay, yes. Then we go on to the next one. Now this one, you see the value of x are all they have until there, except on this line. Can you see the red line here? And this blue line, it cannot touch the red line. Beside, cannot touch the red line. So this blue line has this value, no value x equal to 2. Similarly, when you come from the left-hand side, right, you go down, then you see that the value of x is all covered here. The value of x is covered. Until here also covered. But unfortunately, there's a red line here. And I told you this red line is the asymptote. Huh? So this blue line can never touch the red line here. So that means the blue line cannot have any value that is equal to the value of the red line. So how to say the range in that way? The domain, sorry, the value of x. Right? We see the value of x, the domain. The domain. The domain, it starts from, it has two parts. The first part, it starts from negative infinity. From negative infinity, right? From this side until here, until here. So negative infinity until 2, until 2, but it cannot take the value of 2. So cannot take the value of 2, you don't use this square bracket. You can only use the round bracket. Cannot take the value of 2. Then there is a break. There's a break along this line here, x equals to 2. So there's another part. The other part will be from 2 until infinity. The other part will be from 2 until infinity. So the domain actually consists of 2 parts with a break at x equals to 2. It can occupy any value except x equals to 2. So we say that we say that the x cannot be equal to 2, right? This x here, yeah, this one cannot be equals to 2. X cannot be equal to 2. That means the domain cannot take the value of 2. Other values, 2.01, 2.001, all can. If you come from the left-hand side, right, this one will be 1.9, 1.99, 1.999, but never take the value of 2. Okay, now can you tell me correspondingly what is the range? What is the value of y? Y starts from where? Until where? We take the negative infinity, you go up. Can this y take
Zero.
any value?
No.
No. So it starts from negative infinity until where? Until where?
Here.
You go the negative infinity, they come up, 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 up. Then they go. Did they cross this line? Can they cross this line?
No.
What is the name of this
No.
line? Y equals to 0. The name of this line is y equals to 0. Y equals to 0. The name of this line. The name of this line is y equals to 0. Okay, so this, we cannot take this value. Y cannot take this value. Okay, so we say that they go from negative infinity until 0, but don't put the square bracket there. You put the round bracket to show that they cannot take 0. And at the same time, they, on the other part here, this part here, they cannot take the value of 0. They start from very small value and they go until infinity. So it's from 0 until infinity. So that's why we have 2 parts. Where is it? How to write the 2 parts? Okay, so it's like this. Like that. Okay. Sometimes they write one above the other. Sometimes it is written like this. How to write it? This one again. They write like this. Then this thing put inside there. This thing they put inside. So it will be like this. My computer cannot display. Never mind. So you sometimes they put it inside this type of bracket. One at the top, then another one at the bottom. You put a curly bracket like that. Okay, right. So any question on the domain of this graph and also the range? Any question?
Hello?
Ken, any question on this? You have to break into two parts because there's a line in between. So you skip this value. Now to skip this value, you just put a round bracket there to show that it cannot take this value 2. But it cannot take the value 2. Well, if you use the square bracket, then the value of 2 will be included. Any question on this?
No.
No. Then we look at this graph, y equals to log of x minus 2. This line, it is this line, the blue color line here, the thick blue color line here. Now you see that again there's an asymptote here. The asymptote here is x equal to 2. The reason is because the logarithm is only defined for positive numbers. You cannot have log of a negative number, meaning that this x minus 2 here meaning that this x minus 2 here, whatever that's inside the bracket, x minus 2 here cannot be equal to a negative number. It must be greater than 0. It cannot be 0 either. Huh? It cannot be 0 either. It must be bigger than 0. Right? Bigger than 0. So, in other words, x is bigger than 2. So, this will be our range. This will be our range. X is greater than 2. Sorry, not range, domain. This will be our domain. Okay? So we say that the domain is, better put the square bracket. Okay? The domain is it starts from 2 to infinity. Okay, this will be our domain, right? So by looking at this blue line, can you tell me where's the range? The range. Where's the range? Now the range, actually this blue line can actually go
0.8.
Actually it can go until very low. This line can go until very low. It can go until infinity, but it won't cut the red color line. It will go until infinity. You see that the end here, it didn't touch the x equals to 2, but this line actually can go down, go further down, right? Because the graph here cannot show they go very low here, but actually they can go until the log of a number can be negative. If the number is 0, I show you, no calculator here. You take out your calculator and you type the log of a number, let's say 0.00000001. Oh, you see, it will be equal to -10. So it means that cannot see. Okay. If you type there, log of 0.000001, and you see a -10 there. So it means that this line doesn't stop at -1. It can go as low as possible. If you can think of a very small number, 0.00000, hundreds of 0, thousands of 0 until 1, then you will see that it will go until 100 and 1000, negative 100 and negative 1000. So there's no bottom boundary there. So the range is actually from infinity, negative infinity to positive infinity. The range is actually from negative infinity to positive infinity.
Positive.
On this side also is the same. You can go further and further. This one, this one here. I show you one. It doesn't just stop here. This graph doesn't stop here. You can go further. You stretch until positive infinity. Unless you know how to draw the graph, then you cannot know where is the range, where is the domain, and where's the range, right? So some of the, some of the standard type of graphs, you must know how to draw, right? So in your lecture notes, they have this type of graph. This is a linear function. This is a quadratic one. I don't know whether they show you, because the lecture note that you passed me, they didn't show the modulus type. I don't know whether they ask you to draw or sketch this type of function or not. Right? This one is like just now, this one, the square root type. This one has no name there, so don't worry about this. The square root type is always like this. Right? It's always like this. Only these three types. So I'm going to show you how to draw these two types first. How to draw these two types of graph. Right? Okay. So the first type of graph that they want you to know how to draw is the linear equation, is the linear function. And it is shown as fx equal to mx plus c. Right? Then I think your lecturer typed out this one, y equals to mx plus c. Because the fx and the y, they are interchangeable. They mean the same thing. Right? In graphical form, instead of writing fx, you write y there. But in your calculation, normally you don't write down y, you write down fx. So fx equal to mx plus c, or y equal to mx plus c, they are the same type. Now, we want you to know how to draw this. This one later. Okay, so now I'm going to show you how to draw. Okay, so the first type of graph that they want you to know is the linear graph. The linear graph, they can be, how to say, this linear graph, they actually have three forms. You don't look at the fx, you just look at the y equal to mx plus c, right? They actually have three forms. The three forms, they are xa plus yb plus c equals to 0. Another one is the intercept form, x over a plus y over b equals to 1. This is the intercept form. And the one that is very famous, very popular is this one, y, the gradient form, y equals to mx plus c. Okay, right. Now we look at this. We look at this. This one is the general form. What do you mean by the general form? Okay, so I do over here. Okay, now this general form, ax plus by plus c, is the general form of a linear equation. Actually, it means something like that. 2x plus 3y minus 5 equals to 0, something like that, right? So it means ax means maybe 2x, maybe 3x, maybe negative 4 over 5x, something like that. There is a number in front of x. Then plus by. By means there's a number in front of y, that's all, right? This number, it can be anything, right? Then plus c. So if you see an equation in this form, then it is called a linear equation. You see an equation in this form. And this can be represented by a straight line like this. Okay, it can be represented by a straight line like this. But in this general form, the values of A, B, and C, it doesn't give you any meaning. It doesn't carry any meaning. The values here, they don't carry any. Now, this this general form, I can actually change them to intercept form or gradient form. Okay, this is a straight line. If I want to change them to, let's say, gradient form, so I leave the y on the left-hand side. So I have like that, 3y equals to negative 2x. The 2x bring over to the other side, become negative 2x. Then the negative 5 bring over to the other side, become positive 5. Then I start to divide by 3. Divide by 3, then you have y equals to negative 2 over 3, negative 2 over 3x plus 5 over 3. 5 over 3. So from the general form like this, the general form of a linear equation, I can change it to like this, the quadratic form, right? Not quadratic, the gradient form. I can change it to the gradient form. Now, why do I need to change from this general form, ax plus by plus c equals to 0? Why should I change it into y equals to mx plus c? Why I want to change to this form? The reason is because the value in front here, it carries a certain meaning. The m here has a meaning. Then the c here also has a meaning in the graph. These two values, they have certain meaning in the graph there. So that's why we prefer to change the general form to a linear gradient form. For that matter, we can also change this. We can also change this equation from general form. We can also change it to the intercept form. This intercept form. To change it to the intercept form, you leave the x and y on the left-hand side. Then the the number, you move to the right-hand side. So it will be something like 2x plus 3y equals to 5, right? So you see the x and y, is on the left-hand side, number on the right-hand side. Now, for intercept form, the number on the right-hand side must be 1. So I divide by 5. So I divide by 5. So when you divide by 5, this becomes 2 over 5, 2 over 5x plus 3 over 5, 3 over 5 y equals to 1. Right? So this is the graph, this is the equation in intercept form. I still need to do something. So what should I do? This is x. The 2, I bring it to the bottom here. The 2, I bring it to the bottom. It becomes 5 over 2. 5 over 2. So this is the number. This is the number below x. This is the number below x. Then the number below y is, the number below y is y, then this is 2. No, this is 3. This is 3. This is this. This is 5. Okay. So this will be my equation, linear function in intercept form. So it's like this. Now, what I've shown you so far is an equation in general form, which is not very useful, but I can change this equation in general form to intercept form and also to gradient form. Now, in intercept form and gradient form, these numbers here, A and B, it has meaning. These numbers here, M and C, it has meaning, right? So we look at the first intercept form, right? X over A plus Y over B equals to 1. This one, okay, this one. X over A plus Y over B equal to 1. When the value of A is known, this is 502, the value of B is 503. When the value is known, then it is a constant, or we call it the coefficient of X or the coefficient of Y. But you make it into an unknown, you make this 5/2 into a variable, something that can change, something like a parameter like that, then you will know how important is this value A and how important is this value B. What is the meaning? I have drawn this value of A, I have made it into a slider like this. So this is my value of A. It's over here. The value of A is 1.43. 1.43. This line. The value of A is 1.43. Now, if you see, I move this value of A, I increase the value of A. Okay, you notice, you look at this A here, you see. As I increase the value of A, you see here, you see here, the value of A here, you look at this value of A, 1.22. When I pull this line, the value of A increase, it become 3 point something, 4 point something, 5, 6, 7, 8. Okay, The longer I pull, the bigger is the value of A. Now, how is the changing value of A shown in this blue line here? How is the value of A shown in this blue line here? Now, can you tell me what is this intercept here? This is the x-axis. This is the intercept. It's 8.43. Now, if I decrease the value of A until, let's say, if you look at here, until 5, can you see that the intercept becomes 5? When I decrease the value until, let's say, 1 or 1, can you see that the x-intercept becomes 1?